Hello, today we're going to be talking about different types of graphs and when to use different types of graphs. So we're going to work on selecting the appropriate display for a set of data. Which graph are we going to use, in other words? So let's go ahead and take a look at the different types of graphs that we have and when the best time to use them is. This is a very important chart here. You'll be referring back to this for every one of your problems today. So we have bar graphs used to display frequency of data in different categories, like red, blue, green, yellow. Like if you're doing the colors of M&Ms, how many M&Ms are in a package, and you can do a bar graph to go ahead and do that. Or how many homework problems do you have on Monday, Tuesday, Wednesday, Thursday, so on and so forth. Box and whiskers, well, we just finished doing some of that. That's where we go ahead and we'll break it up into 4 different parts using the different quartiles and the median. A circle graph or a pie graph, compare parts of the data as a whole. So percentages, kind of a deal. We have 25% here and 30% here, and it allows us to go ahead and show it visually that way. Frequency table, compare the number of values in intervals. So you're going to go ahead and just kind of break it up and go ahead and just kind of do tally marks in a table to go ahead and compare that. That's the frequency table. Then we use a frequency table to do a histogram. The histogram is the visual version of our frequency table. It looks a lot like a bar graph, but you're going to display this in the equal intervals. We have a line graph that shows changes over a period of time, and a line plot will display how many times each number occurs in a data set. Stem and leaf plot, we did that earlier in this chapter. It's just a way to list all of our data in condensed form. It's a special type of table. Obviously, we can just do a normal table, list it individually or by groups. And then the Venn diagram displays relationships among sets of data. So when we want to compare multiple sets of data, not just one value of data. So Danielle took the survey of classmates for dessert and revealed that 46% like pies, 32 ice cream, 9 cake, 7 candy, and 6 really don't have a preference. So these are all percentages of the whole. So what kind of one would we use to do this? Again, going back to it, comparing parts of data to the whole. That's a circle graph or a pie graph. And as you see, that's what they kind of have here. Kind of interesting that we have a pie in the pie graph. So a circular graph would be the best one to go ahead and do here. Juan compares the heights of players of 2 lacrosse teams. Juan's team has these heights. The rivals team has these. Set the appropriate set of data type to display in this situation. So probably the best, we're going to be displaying the data. We have 2 different sets of data points, but we kind of want there's a lot of data there, so we want to just kind of display it as quickly as we can. And so a condensed form of displaying data is a stem and leaf plot. And remember, stem and leaf plots can do 2 at a time. So a back-to-back stem to leaf would probably be the best way to go ahead and compare these and look at the data. All right, out of the 40 athletes surveyed, 12 play basketball, 18 play soccer. Of these athletes who play either sport, 5 play both sports. Select the appropriate type of display for the situation. So here we have some parts where we have some overlap. 5 play both sports. So there's only one type of graph here that shows the ability to do some overlap, and that's this Venn diagram down here. So when you have that kind of an overlap that you're comparing different sections together, that's when you want to use the Venn diagram. So that's this one here. Ms. Slater compares the scores of her students in 2 math class, a bunch of data here, and then her afternoon class. That's the appropriate type of situation. Again, we're comparing 2 sets of data, so we probably want to do this back-to-back stem and leaf again. So where's our back-to-back stem and leaf? That's D here. So that's the best way to go ahead. And again, it has 2 different values. These kind of compiled them all together. You didn't want that. We had 2 separate sets of data. So we definitely want something that will show two sets back-to-back stem and leaf. Which graph would best represent the data if you want to show relationships among sets of data? Well, relationships and whether or not they overlap would be the Venn diagram. Which graph would represent the data you want to show how many times each number occurs? So we're talking about a frequency. And so a line plot. Let's try a couple more. Select out of 195 mothers, 42 have only one child, 67 have two, 34 have three, and 22 have four or more children. So there's not an overlap situation going on here because none of that overlaps. You either have those or don't. So that's not good. So this one's not good. It's not really a stem and leaf because it's 67 have this amount and 34 have that amount. You could argue the pie graph. I wouldn't be too upset with that, but probably the best is just showing some sort of frequency. One child, two childs, three childs, four or more children would be a better way. This would be the best way to display that information. Again, they chose this one. I disagree. I think this is the best here, down here. All right. To represent this data, we just got a bunch of data. So this pie graph here, looking at this is just a mess here. There's no way that we want to do that. And these dots are all over the place, and they tried to connect the dots here. I don't think either of those are valid. So probably the best way to go is just here with your stem and leaf. And it tries to go ahead and organize it and condense it a little bit more. Select the relationship, display the relationship among people who have one pet, two pets, or no pets. So there's no crossing over because they either have those. They either have one pet, two or more, or no pets. So there's no crossover, so we don't want that. So either of these three probably are okay. If you're going ahead and just looking at the one type, seeing the different percentages would be a lot easier. But if you had said either of these, I would have been okay with them. And as you notice with some of those problems, there are some multiple answers, and that is valid. Okay, some of those graphs do end up showing a lot of the same data, but make sure that you choose one of those that is good. As long as you choose one of those few that are good, like that last one had a couple of them, they'll be okay. But definitely don't. There are ones that are definitely do not use for different ones. Please do not choose those. All right. So that's what I have for you today.